Hello, everyone. My name is Abhinav Srivastava, and I'm a VP and the head of information security and infrastructure at Frame.io. At Frame, I'm building the security infrastructure programs from ground up, making sure we are secure and compliant, and our services are available and reliable. Before joining Frame, I spent a number of years in AT&T research, and before that, I spent 5 great years in Georgia Tech on a Ph.D. in computer science. Today, I'll be talking about Janus, a multi-party authorization framework for accessing critical cloud resources, a system that my team has built. Before I talk about Janus, let me quickly tell you about Frame.io. Frame.io is a cloud-based video review and collaboration platform that allows users to securely upload source media and work-in-progress videos, and users can invite their team and clients to collaborate on uploaded assets. We are building the video cloud. We're not a creation tool, we are a collaboration tool. So you can think of us as a GitHub for videos, and we are entirely hosted in Amazon AWS. The first thing that Frame.io allows these teams to do is communicate clearly on videos. Users can annotate and comments on videos that gets actually embedded and connected to the video frame itself. That allows easy navigation. The second is Frame.io acts as a secure hub for film productions, where teams can control who sees what and when. It also lets teams easily organize and manage the versions of each asset. Frame.io also allows teams to share content with external partners in a secure way, and teams can customize how and what others' sites see. While we are not an editing tool, we provide integrations with all the popular editing systems like Adobe Premiere Pro, Avid, Apple Final Cut Pro, and DaVinci Resolve Studio. These integrations allow editors to upload directly to Frame.io and then organize and share their products both internally as well as with external clients. So let's look at the platform that actually powers those features. At the infrastructure level, we have two kinds of clusters, ECS and EKS, to process two different workloads. On workload, one workload is related to users' web requests, another is where we do video transcoding. The transcoding pipeline generates low resolution proxies for the uploaded videos so that even resource or bandwidth constrained devices can perform review and collaboration. All transactional data is stored inside the database, and the media is stored in S3. Since the sensitive data is stored in the database and in S3, we at Frame.io, and I'm sure it is same in other companies as well, have few roles that have access to these critical resources and data is stored within it. For example, few DevOps and security engineer roles are allowed to access the resources. The reasons for access are also very common, and it is same across many companies. Troubleshooting during customer issues, maintenance and backup purposes, and during the on-call shift to respond to P0 incidents. However, as team grows, we add more and more engineers in the team with those roles. And very soon, you would have not two, three engineers accessing critical resources, but 15 to 20 people accessing production database in S3 buckets. And this problem can get worse over time. This is the inherent problem with the coarse-grained role-based access control. If you are a part of a role, you can access everything available to that role. If you want to change anything, either you change the membership of the user or you go and modify the role itself. There are other problems associated with RBAC explosion. First of all, lack of transparency. Sometimes we don't know why a cloud engine is accessing critical resources any given time. Two, unfettered access to critical resources. Since a role is allowed to access a resource, the person with that role can access data anytime without any checks. The access to sensitive resource is also permanent as long as the role is allowed to access it. As I said that, you cannot immediately revoke it without changing either user's membership to the role or limiting role's permission itself, causing disruption. And finally, instead of proactively, you would know the effect of an action taken by the user always after the fact. And then you have to chase the person down in order to confirm whether he or she actually performed that operation or not. To solve the previously described problems and allowing controlled access to critical resources that contain sensitive data, we designed and developed a system called Janus, which is a multi-party authorization framework. And the rest of the talk, I'll describe why we build the system and how we build it. So if you go to Wikipedia, multi-party authorization is described as a process to protect a telecommunications network, data center, or industrial control system from undesirable acts by a malicious insider or inexperienced technician acting alone. MPA requires that a second authorized user approve an action before it is allowed to take place. This proactively protects data or systems from an undesirable act. As you can see in the slide, I have highlighted a few keywords here that are important from security perspective. Protect, undesirable acts, malicious insider, acting alone, second authorized user, and finally proactively. And these keywords are associated with the problem that I described earlier. So, to solve these problems, we came up with 6 requirements for an MPA system in the cloud. First, defining who should be able to request access to protected resources. Only certain people should request for additional permissions. It's not that anybody can ask for a new role or new permission. People should have a base level of permissions already in order to request extra permissions. Define who should be able to approve these requests. Not anybody should be able to approve those requests. You should have proper checks and balance there as well. How and where such communication should take place. How to make this process highly visible both for the requesting party and for the approving party. How we should be able to revoke granted privileges when the task is done. And finally, the whole request and response process should be auditable and should meet the compliance standards. Janus satisfies these requirements. In Janus, we have a pool of users that are already identified from key teams to request additional privileges to access critical resources. We have a set of approvers, generally engineering leads, to approve those requests. Slack is the medium that we chose to communicate between requester and the approvers. Dedicated Slack channel is created to broadcast such requests and responses to make the process highly visible. Janus uses a novel on-the-fly temporary roles mechanisms to allow and deny access. And finally, it uses database to store all communications between parties for audit and compliance. To implement Janus, we used AWS serverless technologies. In particular, we used API Gateway to allow HTTP requests from Slack to come to AWS, Lambda functions to process those requests, SNS to pass messages between services, step functions to coordinate among multiple Lambda functions in the serverless workflow, as you will see later, and DynamoDB to store all transactions for audit and compliance purposes. There are many benefits of using serverless technologies. First, no servers to manage. So you don't have to worry about patch management and managing our own servers just for Janus purposes. It offers continuous scaling, so it is managed by the cloud provider, and we don't have to worry about peak demand or anything. It also very cost effective because we pay on each invocation, right? So anytime Janus is invoked, then all these systems will be used, and that's when we have to pay the cost. We don't have to have a running VMs and containers all the time. And finally, it's a faster time to market by just focusing on the logic. We don't have to worry about runtime, software development, and setting up development environment and so on. Okay, so now let's look at how Janus works. To keep the presentation simple and easy to follow, I have broken down the complete workflow into smaller subflows. I would first present each of those subflows from an end user's perspective who is interacting with Janus, and then explain corresponding behind the scene serverless workflows. So, a user who needs elevated privileges to access protected resources first activates Janus by a Slack command /security allow access. As soon as the command executes, the user is presented with a Slack form. As you can see, the Slack form has some obvious fields such as name of the service, environment, production, development, and staging, duration of access, and the most important field, reason of access or explanation. Clear explanation would help approvers decide how to respond to a request. And after filling out this form, user presses the submit button and the request goes to AWS. Behind the scene, uh, when the user runs allow access command, the HTTP request goes to API gateway, and the associated Lambda function gets invoked. The Lambda function performs authentication authorization checks, parses the command argument, and creates an SNS topic called allow access, which is picked up by another Lambda function, which is listening for that topic. On receiving the message, the Lambda function sends the user a web form on Slack that we saw in the previous slide. And the user is going to fill out that form in order to complete its request process. So let's look at the approval process. When a user submits the form, the above message is posted on its chosen Slack channel with the approve and deny option. As you can see that John Doe has requested elevated access, and now this message posted on the Slack channel that we have chosen for Janus purposes, and everybody can see that there's a new request, and now explanation is that need to access bucket for fun. Let's see what happens. So if someone is accidentally added to the Slack channel and tries to approve a request, he or she cannot do so unless they are part of already chosen approvers. As you can see that Jane has insufficient permission to approve the request. If she tried to approve my request, and it was considered an invalid operation. And if the request is denied, it means it is denied. You cannot approve it further. So since my explanation was need to access S3 bucket for fun, my request just got denied. When two users approve the request, then it is approved. This time my request was genuine, as seen in the explanation that needs to access S3 bucket to troubleshoot an ongoing incident. And it was approved by two approvers, approver 1 and approver 2. You need minimum 2 approvers to approve a request. And that's the multi-party authorization framework. You need second person to approve the request. So this is the flow that describes behind the scene approval process. I know it looks complicated, so let me describe it. Again, it is a combination of API gateway, Lambda functions, and SNS. The DynamoDB table stores all the requests and responses. The top flow shows that what happens when you submit a request form and when you get a message back from Slack. It again goes to API gateway, Lambda functions associated with it parses the request and generates allow access request notification topic as shown in green. And it starts the approval process by sending the message on Slack that we saw in the previous slide. The bottom flow executes when someone approves or denies the request. It again goes to API gateway and the Lambda function, and this time a new topic is generated called allow access approval. And new Lambda function picks it up, and it goes all the way to Lambda function, the black circle, which takes care of sending message on Slack. The Lambda function also updates the dialog box on the Slack as soon as more approvers approve the request. So keep everybody informed on how the process is working out right now. The Lambda function, the white circle, takes care of dynamic role creation that we will see in the next slide. So now let's look at the temporary role creation. So as we saw in the previous slide, that two approvers have approved my request, and at the time the access period is started. So we have created the request, submitted the form, and got two approvals approve the request. Now you can see the new role is created. New role is created called security role name. And the account ID shows that which account it is for. So if whether access was for production, then role will be created in production. If the access is for dev, the role will be created for dev. And at this point, user can use this role and assume this role and actually perform the operation. And after the requested duration, the role will be revoked. And here you can see that the user is notified after the end of a granted access period, the role is deleted now. So let's look at the behind the scene working. So behind the scene, we use a step function to implement this logic. Step functions coordinate between these Lambda functions by creating a state machine. It automatically triggers and tracks each step and retries when there are errors. So the application executes in order and as expected. The first three Lambda functions work sequentially to create a temp role and notify users on Slack. Then the state machine pauses for the requested duration of access. In my example, I requested access for 60 minutes. So this state machine would pause for 60 minutes. And then after that, it resumes and sequentially start the cleanup process where it notifies a user that his role is about to be revoked. It detaches the role associated with that user and basically deletes the role. And this is how we implemented the temporary roles, which are created on the fly and deleted on the fly, and the entire multi-party authorization workflow. There are many benefits of a system like Janus. First, it gives you full transparency, who did what and when. It also offers peace of mind to enterprise customers, knowing no one has unfettered access to their data. We don't have to give them the list of users who can access the data every time it's decided based on their need, and we can monitor those requests. It also helps alleviate the need of weekly, quarterly access reviews to sensitive data because everything is on the fly and roles are revoked after the job is done. And finally, it prevents accidental and intentional mistakes. And that is the most important part in the cloud, that anybody can make mistakes. And with this process, we try to create guardrails around sensitive data. The three main takeaways from this presentation are: trust but verify. Trust alone is not sufficient. A system like Janus creates better accountability. Dynamic temporary roles is the solution to many problems in the cloud and helps solve RBAC explosion problems. And finally, serverless technologies are great in developing security systems in the cloud. At Frame, we heavily rely on serverless resources to design and develop security automation and workflows. That's all I had. Thank you for listening. Please use the link here to provide your feedback on the talk, and we are hiring. So please visit the job posting at careers.frame.io. And at this time, I'll take a few questions. Thank you.
Thanks, Abhinav. So I think the number one question on the Slack is that this looks great. Do you have any intention of open sourcing it?
Let me repeat the question. The question is that whether this system is going to be open sourced.
Yeah.
Yes, so we are thinking about it. We are trying to make it work, that how we can release the system and generalize it so that others can use it and remove the logic that are specific to Frame.io, and we are actively working on it.
Thank you. Another question was, how do you avoid the security team becoming a blocker if they have to approve every request? So is there the right number? What is the right number of approvers per IAM role or action?
That's a great question. Yes. So this process actually solves that problem because we don't have to decide which role should access the sensitive data. And the way we have chosen approvers, we have chosen key people from each department that should know about when any of their team members accessing the data anyways. So right now we have a 7, 8, or even close to 10 approvers right now. It's like few from security team, few from SRE team, few from engineering team. Even the back end and front end engineers are also involved. So goal is to make the process highly visible and create accountability. So anybody who's accessing that, sometimes we just need 2 approvers at this point, and they can get their request approved. So there are a lot more approvers right now who can approve the request while making sure that all access is legitimate.
Cool. That makes a lot of sense. One more question, and that is, are access requests one time? How often do you change the list of what roles someone can request?
So the question is that who can request it, or
so how the questions are around customizing the roles and approvals that can be requested. So it sounds like you have a specific role that people can request. What do people do if they need a different role than they've needed before?
Right. So this process, that the system that we designed is specifically keeping sensitive resources in mind, right, or critical resources in mind. So right now our system supports S3 and the database, where we keep all our sensitive data. But it's very easy to add new resources because behind the scene you have to just create a new IAM role on the fly that can take new resources into account as well. So system is pretty generic, and that's why I took out some of the details in my architecture slide, but then the way we wrote the system, that you can add new Slack commands, new resources, and all those things can be added on, and system is very extensible. Does that answer the question?
Yeah, I think it does. So thank you. And then I think the last question that I have is, how do you handle a break glass situation? So this is a potentially complex system, and it's really important to prevent people from getting access to data. But if it goes down, what do you do to ensure that you have a way in if Janus is not working?
That's a great question again. Yes. So at the end, we do have 1 or 2 persons who have still access to that resource, those critical resources, and those people are up in the high level chain, the leadership, that if they have access to, and they can be used to break in break glass situation, because if the Slack goes down, our communication channel will go down, and somebody has to access that, then those people will approve those requests.
Great.
And we are also working on adding additional communication channels like SMS or some other ways, so that if the one communication channel goes down, the other communication channel can be used to request and approve, to request access and approve the request.
Great. Well, thank you very much. Just remind everyone if you could leave your feedback at the link we have in the Twitch stream, bit.ly/FWDCS-3. We're aware there are some audio issues, so after this, we're going to flip the stream. It should take about 15 seconds. But we'll be back at 12 o'clock with Narayan and the security onion approach towards IAM roles. So thank you very much, Abhinav.
Thank you, Az.